Now another example of how we're going to change just the period of our sine and cosine functions is working with cosine. Again, I want you to recognize that this is the b value. Right? Now you're going to look at this to go through the same process. You're really looking at it in terms of if I have 1/2 times x and I were to set that equal to each of my input values, what would I need to do to start changing their position? And because this is a 1/2, I'd be multiplying both sides by 2 to start doing some work to that. And so that's what you're going to do, again, to all of your thetas. Again, just like with the sine graph over here, when it said 2 times x, we actually did the opposite, and we were taking 1/2 of that. Now we're going to do the same thing for here. Instead of it being 1/2 of x, we're going to multiply everything by 2. All right? And so that's going to be what we do to modify all of our thetas and get their new placement. So I'm going to multiply all of my thetas by 2, and then I'm going to have to simplify down my fractions. Again, 2 times 0 is still 0. 2 times pi over 2 leaves the pi symbol in the numerator, but the 2 in this numerator cancels out with that 2 in the denominator. Right? 2 times pi is just 2 pi. And again, this 2 is going to cancel with that 2, and I'm going to get a 3 pi and then 4 pi. Right? So if you have a struggle with trying to multiply these fractions really quickly in your head, you can do that quicker on a calculator. You're just going to leave the pi symbol alone. That's still going to be in your theta, and then you're just going to have to multiply the fractions together. And so what you're going to notice is that when you put a fraction as your b value, that's going to actually lengthen our function. So none of my cosine values actually change in terms of the y values. All right, again, this was only happening to the x. If I do my order of operations, once I change this, my output is still the same cosine values as before. Right? So again, amplitude-wise, for this example, there's no number in front of my cosine, and I'm also not adding anything. So my amplitude is just 1. All right. So now when I take my period and I do 2 pi divided by b, all right, 2 pi divided by a fraction means I have to multiply by the reciprocal, and that's going to change it to 4 pi. All right. And again, you can see that between 0 and 4 pi, that's my length. My domain, again, now starts at 0 but ends at 4 pi. And my range has not changed, and neither has my midline. All right? Again, there's no adding or subtracting happening to cosine. And so I want to look at what that's going to do to my graph now. So what I'd like to do, so let's look at this. So y equals cosine of 1/2 of x. What I'm going to do is I'm going to try to make a graph that's big enough for all of these, and then see if I can also put my regular cosine on there. See if I have space for that. All right, so let's make our graph. All right. 1 to -1. All right. And now what I'm going to do is I'm going to try to spread this out just a little bit. So I'm going to make this right here my pi, 2 pi, 3 pi, and 4 pi. And so what I'm doing is as long as it's evenly spaced, like I'm putting a gap between the first pi, a gap between the second pi, and so on, then as long as it's evenly spaced, you can spread this out and use more of the graph. All right, and what that does is that puts here, that's half, so that's a pi over 2. All right, that makes this 3 pi over 2. And so a normal cosine graph, all right, so let's not graph this yet. Let's just go back to the normal cosine graph. The normal cosine graph, lengthwise, looks like this. All right. And so what I want to do is I want to see how did putting a value right here change that. And that's where I'm going to plot these points. So again, this first placement didn't change, but now I have to go to pi to hit back down to 0. So what it's doing is it's stretching it out farther. And then at 2 pi, I went to -1 and then back up and then back up. And so what it's done is it's putting a 1/2, putting a fraction next to that x has actually made it take longer to get to my initial interval. So you can see that it actually took my regular cosine graph and just stretched it outwards. Right? And so that's what changing the period for sine and cosine is going to do.